Senko AP Physics Experiment Number 10, Rotational Motion. Students will explore the relationship between the linear tangential and angular velocity. They will make measurements to calculate the angular and the tangential velocities as they vary the radius of the circular path. Students will design an experiment to determine how the radius of a circle affects these two velocities of an object in circular motion.
The kit includes a motor-driven rotational table, ruler, and calipers. Required but not included are a 6-volt power supply and a photogate system.
First thing you want to do when you get the rotational motion table out is to get all the pieces out and unscrew this top bolt with the washer. You're going to be putting that on top of the disc and then screwing this onto the stand. The next thing you want to do is take your vertical support rod, the longer one, and secure it into the hole on the base. This little short rod is intended to go into the bottom just to help give you something more substantial to use to secure this in. Okay, then you have a cross clamp. You put that on here, and then that allows for you to put in a rod that will hold your photogate. The last thing you're going to need on this is one of the rods to put into the holes so that the photogate has something to read. Okay. Once you're done, all you need to do is connect the power supply and it's ready to go. Now once you get this set up, preset the motor so you know that the disc will spin at a constant speed, and I have 2 pegs set up that go through a photogate. This is set to a mode of measuring frequency, so that way we can measure the frequency in which the pegs go through. So when I turn this on, just give it a little spin to get it going. You always let it come up to speed no matter what voltage you place on the motor. Once it gets going up to speed, it's going to measure a frequency of about 1.8 Hertz. Now if you were to stop it and move this to measure the frequency of the inner peg, students are going to find the frequency is exactly the same. Reason for that is everything on this line is on the same disk, so it's all going to move around at the same frequency, but not at the same velocity. So what students can then do is look at the circumference of the circle that that peg is traveling, figure out this distance, and then using the time from the frequency, determine the linear velocity at each peg, and show how it's very different than the angular velocity. Another great thing you can have the students investigate with this is the difference between a DVD and a record player. All along the disc there are equally spaced dashed lines. Those can represent data points on a DVD. The students just learned that the object travels faster on the outside than it does in the middle, so if a DVD is to read the data consistently, this disc has to constantly change speed in a DVD player. Unlike a vinyl record, which is constantly turning at a same speed the entire time. You put some clay on the bottom of this and then thread this through, and you can show students how a record player works. Now you're going to have to play with this ahead of time to get the right speed because there's no RPMs on your power supply. But once you get this going, you just make a paper funnel, put a needle through the end of it, and use a vinyl record you're not overly fond of because this might scratch it up, and then just show the kids how a record player works. I'm going to drop the needle right on here and see what we can hear. Very simple phonograph. You're going to have to play around to get the record up to speed ahead of time because there's no RPMs on the power supply. Then take a piece of paper, wrap it into a funnel, tape it, put a pin through the end, and then you just show kids how a record player works. And there we go.